Good afternoon. Today's AeroSense demonstration is going to be specifically for the judges. As was demonstrated at the World Aerobatic Championships in Spain this year, there were several contentious issues with the line judges. It was some of the pilots and some of the judges perceived the line judges to be judging unfairly. So the focus of AeroSense the last couple of months has been specifically to demonstrate that our system can track box outs and box lows. The pattern that I'm going to be flying today is through the box down the A axis and then coming cross box flying along the B axis, and that's through the box above 1,000 feet above ground level. Then I'll also be coming below the box altitude, which I'm going to deem to be about 700 feet, fly through along the A axis and the B axis to demonstrate that the system can record box outs and box lows.
As a bit of background, this is the Google Earth representation of the airfield that we flew at. This airfield is located in Cape Town and is an old Second World War airfield called Vasantokrál. The two runways is a north-south runway, which was always the A axis, and the east-west runway, which we use as the B axis.
We're using a standard Bluetooth GPS linked up with Bluetooth to a iPack running Windows Mobile on it. Our software then takes those files, output from the GPS, and has a three-dimensional representation of the flight. At present, we don't have any roll, pitch, and yaw data. That is going to be the next step, provided we can demonstrate that this system works accurately using just the GPS data. Right, let's go fly.
This is a plot of the altitude of the aircraft during the aerobatic flight. The aircraft's altitude is represented by the red line, ground level is the green line, and the bottom of the box is the blue line, and the top of the box is this blue line above it. The initial part of the recording is on the ground, followed by takeoff and repositioning the aircraft along the A-axis. This is a flight horizontally along the A-axis, followed by repositioning and flying along the B-axis. This is erect flight. Then descended to just above the runway, flew along the A-axis and the B-axis. Then climbed out back into the box, had a full roll, followed by repositioning, and then a half Cuban. So that's the looping section over here, followed by the down 45 and a half roll. I then flew up 45 erect, followed by half roll, and then inverted 45 up back into the box. This is a plot of the aircraft's flight path along the x-axis, or the main axis, or the A-axis. This is a plot of the aircraft flying along the y-axis, or the B-axis. The red line is the flight path, moving in and out of the box along the B-axis. The blue line represents the box, and the green line is the 50-meter buffer zone on either side of that box. The red line deviates throughout the flight in the box and out. It's reasonably easy to count the number of occurrences that the pilots flew outside the box.
The next step up will be to record roll, pitch, and yaw, and that will be integrated with the GPS data to demonstrate the full 6 degrees of freedom. Obviously, the GPS data is tailored more specifically for the judges, while the roll, pitch, and yaw information will help the pilots critique themselves when there's nobody on the ground to watch them.